Well, good afternoon, everyone. Dr. Reynold Lewis here. I'm the professor, of course, teaching ED 929, mathematics for culturally, linguistically, and diverse learners. Today, my objective is to help you to see how you could use pattern blocks to effectively solve problems dealing with fractions. You recall the activity dealing with Ling Chen and the candy bar problem, in which Ling Chen was able to conceptually solve the problem using manipulatives, pattern blocks in that case, and how when she was asked to represent her answer symbolically, she encountered a lot of difficulties, and I would say procedural difficulties. So her main strength was that she had good conceptual knowledge of fractions, but poor procedural knowledge of fractions. This recording is intended to assist you with providing CLD learners with a technique, with a strategy that they can use so that they could see what they're doing as they work with concrete materials. So I hope that you will get out your pattern blocks, and I have a few demonstrations here. I will have you follow along, and any issues you probably could email me so that I could probably clarify that. But we want to use two yellow hexagons to represent one whole. Two yellow hexagons, that's the whole. If that's the case, then notice these are trapezoids, red trapezoids. And so I have come up with a representation of equality. So 4 red trapezoids will represent the whole as well. And similarly, these are rhombi. 6 of them represent the whole, 1 rhombus. Then here you have green triangles. You have 6 of them, 6 here and 6 there, 12 of them representing the whole. So based on the fact that we're going to use 2 yellow hexagons to represent the whole, then we can say 1/2 would be 1 yellow hexagon. We can say that 1/4 will be 1 red trapezoid. 1/3 will be 2 blue rhombi, and 1/12 would be 1 green triangle. Hope you can see that. I'm getting a little glare in here, so I'm hoping that it doesn't come through in the making of this video. So I want to begin by looking at the fraction 1/3 plus 1/2. So I'm hoping that you will be able to model, take the symbols and represent them with fraction pieces. So here is 1/3 plus 1/2. What would 1/3 be? Well, we say this would be 1/3. So here is my 1/3. And I want to add to that 1/2. Well, here is my 1/2. I'm going to use this one here. Here is my 1/2. So together, that's my answer. That is my answer. But what is this answer relative to the whole? Well, let's see. If this is my answer, I actually could do this. I'm going to go for the smallest piece. So let's see, I could represent that, this, that would be my 1/3, and then my 1/2 I could use a variety of things here for a half, but I'm going to use the smallest pieces I have. So that's my half. And so altogether I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1/3 plus 1/2. Look what it gives me. Give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 what? 10 twelfths. 10 twelfths. But you know that 10 twelfths really is a fraction, yes. But we could actually simplify this. Let's see how we could simplify that. Okay, so there. 1/2. Okay, so we have our half there. That's a half. Okay, so we have, that would be that, and we can take 2 of these. Okay, so we're looking for equivalence. You can see clearly that this arrangement is equivalent to that, but we know that this is 5/6. But what is this? Well, it's the same representation. So let us now think of this representation in terms of blue rhombi. You know that 3 rhombi would be here and 2 here, so that would be 5/6, because we know that a blue rhombus is 1/6. I don't think that I have that over here, so I'm actually going to put that, add that to the list here. So equal 1/6. 1/6. So altogether, this would give me 3 blue rhombi here, 4 and 1, 5. So my answer would be 5/6. 5/6. And you know that 5/6, we said initially the answer was 10 twelfths. We know that 5/6 is equivalent to 10 twelfths. Okay, so what I want you to do is to allow the manipulatives to speak for themselves with your thinking, your conceptually, I would say, powerful thinking. Forget about the procedure. You already know how to do the procedure. Yes, when you're done, you probably could check it with your procedural knowledge to ensure that it's correct. So let me back up just a little bit. So we're looking at 1/3 plus 1/2. We've established that 1/3 is equal to 2 blue rhombi. So here is my 1/3 plus 1/2. Here is my 1/2. So together, this actually is my answer. That's my answer. Well, at that point, then, I can say 2 things. I can say, well, that is 1 blue rhombus, another blue rhombus, and if I exchange that with these, I have, for my answer, 5 blue rhombi. But each blue rhombi is 1/6. So then my answer is 5/6. If you look at the mathematics with manipulative sheet that I gave you, I would call that a script that I gave you, you would see how to write it up precisely the way I verbalize it, but you will write it in words. So that would be the first problem. Remember now, you really don't want to allow your previous knowledge of how to use the LCM. It should play a part, but you're already trying to think conceptually. So here's the second problem. 1 1/3 minus 3/4. So I'm going to clear the board here. Clear the board. 1 1/3. So remember, this is my whole. That's my whole. That's 1. And what would 1/3 be? We say 1/3 would be 2 blue rhombis. So here is my 2 blue rhombis. So when you think about it, that's actually, oh, we're subtracting, sorry, we're subtracting. So here is 1 1/3. That's 1 1/3. And we want to subtract 3/4. In other words, we want to take away 3/4. Remember, subtraction is an operation where you are operating on what you have. This is what I have. I want to take away 3/4. So here's what I'll do. I'm just going to do a simple trade here. I'm trading these 4 red trapezoids for the whole. So this is another representation of 1 1/3 minus 3/4. So now I'm going to subtract 3/4. And that will be my answer. I've taken away 3/4. So now you need to put this together for your answer. That's my answer. But what does it mean? Well, let's see. If I take the smallest piece I have here, it'll be 2 of them here, 2 of them here, and 3 of them here. So 2 and 2, 4, and 3, 7, 7 of these, 7 of those. So let me do an actual. All right, so we have, so that's that. We have this. Seven of these. But what are those? Originally, we said that that was a 12. So I have 7 of them. So I expect that my answer would be 7 12s. Or I'd like for you to write it in words. 7 12s. 7 12s. Let me try that again. We have 1 1/3. Here's my 1. 1/3. And I would like to subtract, take away, diminish that amount by 3/4. Well, I don't have fourths. I know that that is a 1/4. So 4 of them, I'm going to do a simple trade. I'm trading the whole for that. So this is my new representation of 1 1/3. Now I need to cut off, subtract, take away 3/4. 1, 2, 3/4. This is my answer. That's my answer. So that is a whole, which would be represented that's a whole plus an extra piece kicking out here like that. I think is actually out here. You got 1, 2, 3, 4, 5, 6, 7. 7 green triangles, and each green triangle is a 12th, and so my answer is 7 12s. Okay, I'm going to proceed to the third representation, 2.5 minus 3/4. 2.5, 2.5 divided by 3/4. Now, division is actually a kind of a covering activity. It's a grouping activity. It's like a cutting out activity. If you have a pattern and you have a certain measurement for pattern, how many times can you cut the pattern out? So we will begin with 2.5. So let's start with our whole. That's one whole. That's 2.5. That would be 5 of them. 1, 2, 3, 4, 5. Whole, 2 wholes, 1/2. Now I want to divide by 3/4. So here's my 3/4. And essentially what I'm trying to do here, I'm trying to find out how many times can I cut this 3/4 out of this. So you can see right here, I can cut it out one time and that will remain. And then I can cut it out another time. This will cut that out one more time. And then over here, this will cut this out one more time, leaving this. So this is actually what remains. The question is, how many times can I use my divisor to cover that? How many of these can cover that? 1 of the 3. In other words, this divisor will cover this only 1/3 of a time, 1/3 of a time. And that will tell me that my answer will be 3 and 1/3. I'm going to try that again. So here is my 2 wholes and 1/2. I want to know how many times I can cut out this shape, this exact shape from that. You can see clearly, you have 2, 4, 6, 8, 10. Every time I cut out 3 of them, that's 1 whole. So I can cut it out 3 times. That will give me 9 red trapezoids. And I have 1 more. 1 more like the remainder. And this divisor could overlay this remainder 1/3 of a time. In other words, only 1 of these can cover that, my remainder. 1 of 3. That will give me my answer of 3 times and 1/3. Now, if you actually want to, let me just see if I can simplify this even more. I'm going to need quite a few. So that's my, I'm going to do a representation here. That's that. Okay. So 1, 2, 3, 4, 5. Every time I take 3/4 or 3 of them out, that's 1 time. So that's 1 time. That's 2 times. That's 3 times. And a third of a time. So my answer there would be 3 and 1/3. Notice we're doing it conceptually. We're not using the procedure of invert and multiply. That is still correct and it still works. Okay, we'll go to the third problem. 2.5 divided by 3/4. So I think that's what we did. Let's go to the fourth problem. 1/3 of 3/4. So we will begin with 1/3. So here is, well, actually, I'm sorry about that. We're taking a third of 3/4. So we must begin with 3/4 because we want to take a third of that. So here is my 3/4. I want to take a third of that. That means if I'm going to take a third of anything, I need to have 3 equal groups. So I am going to put them in 3 equal groups. And take one of the 3. That would be a third of it. That would be your answer. Whatever that is your answer. You look over here, you realize that your red trapezoid is 1/4. So a third of 3/4 is equal 1/4. How you write it up? Take a look at the mathematics with manipulatives script that I provided. You can find that on this week's materials, and you will see how it's written up. The way it's written up here is precisely the way I've just presented it to you, and that would constitute your conceptual knowledge of working with a new set of fractions that I've given you. So off the cuff, I'm going to try another one. Try another one here. Let's say that we want to find 2/3 of 1/2. 2/3 of 1/2. Well, we need to have a half before we can find 2/3 of it. So let's begin with a half. That's a half. That's a half. I want 2/3 of it, but right now I only have one piece. So I have to do something to my whole. I have to partition it in such a way that I have 3 parts, and I can easily do that. I'm going to trade these 3 rhombis for my half. Now I have 3 of them, right? I must put them in 3 equal parts. And I want 2 of the 3, or 2/3. So this would be my answer. Whatever this is my answer. I look across here and I realize, oh, look, that is 1/3. So my answer would be 1/3. So I've given you a short lecture, so to speak, in adding, subtracting, dividing, and multiplying fractions. And I would like to see when you do the activity that you try to represent your fraction conceptual knowledge pretty much the way I've presented in this short video, and how it has been written verbally on the sheet I gave you. You probably can call this a kind of a script that goes along with this presentation. So see you on Tuesday when Dr. Reese will talk to us about cultural humility. And I hope that let me say this. Many of you are a little nervous about the quizzes. I want you to focus on allowing this course to move you along in your relationship to CLD learners, in your acquiring of new knowledge. But while you're doing this, I know that students like to focus on the grade. the grade will take care of itself. Once you apply yourself, and I know whether you're applying yourself or not, I can tell by the quality of your work. You focus on that, and the grade will take care of itself. If there are serious issues with the grade, I'm certainly available to deal with that. So I've actually tried to do a few things to help you out. I'm going to give you a fifth quiz, which will be a repetition of some stuff that you've already had in the first four. And I will use that for you to replace any one of those previous scores. It'll be a rehashing of the materials, and I hope that you all will do well. I don't have an issue of you not doing well. If it is, as I said, I'll be available for consultation. Well, take care. That's all for now, and hope you have a good rest of the day.